If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where you are solving previous year IIT JEE questions on differentiability. So in this lecture we will be solving from question number 1 to question number 4a. Okay, then let's try to solve these questions. Okay, in question number 1, the function fx is equal to this is not differentiable at. Now if you look at this function, this plus this, if you look at cos mod x, so cos mod x, cos, if you give plus x or minus x, the outside is always positive because cos digests that minus. So mod x can, if you can expand mod x in two parts, either one you will be putting x or you will put minus x, but both this case output will be only cos mod x. So cos mod x doesn't make any sense, it simply means cos x. So there is no difference between cos mod x and cos x. Whatever below, the output will be same only. So that's why, because it will look like a simple cos x they have given, so it's a differentiable at all points. So if it is differentiable, now you think on this. Differential plus differentiable is always differentiable. Differential plus not differentiable will be that you have to think. Differentiable into that also. So that's what we have to see, whether it is not differentiable at. Now if you see this function, see this one, x square minus 1, and if you factorize it will look like this. So to expand this function I have expanded it here, so that you get easy understanding of this one. So this one has a two breakpoint at 1 and 2. So let's think about, you have already seen this, you put a pole here 1 and 2, and the right side start writing from this side in quadratic. I have explained you in inequalities. So in where it will be negative, in between 1 to 2 it will be negative, above 2 it is positive, minus below 1 it is also positive. So if you come to below 1, then the output is positive. Why it is positive? Because this is also negative, this is also negative, so product will be positive. Then there is no need of mod. So that's why if it is less than 1, it is simply x minus 1 into x minus 2. If it is between 1 and 2, then this get positive, this is negative, so the output is negative. So that's why I put in a minus sign. And if it is greater than 2, then this is also positive, this is also positive, so it will be, again there is no need of mod. So now if you, and in front of that there is x plus 1 into x minus 1. Now if you simplified this one, it will be x plus 1, x minus 1 whole square, then x minus 2. So this is the portion. So the function is a polynomial function and it is piecewise defined. So obviously at minus 1 and 0, if you see option 1, minus 1 and minus 0, so at minus 1 it will be this one only. So any polynomial function is always differentiable. So option A will not be the answer. That's why option A you neglect. Similarly, you come to option B, at 0 it will be same this function. So only one single polynomial, so no break is there. So a polynomial is always again a continuous. So again B will not be the answer. So your answer may be at 1 and 2. So that's what you have to check. So one can do you can do left hand derivative at 1, right hand derivative at 1. You differentiate this differentiation, but this differentiation may take some time, and you can differentiate here and here. So without differentiating also you can think of what will be your left hand derivative. So if you differentiate this one, that's why I am checking at 1. So here it is written f, I have considered this is f, this is g, but you can think of, if you differentiate this one, those who know differentiation, so how do you differentiate? You think that these two are one side and x minus 1 side. So first you keep this one fixed, then differentiation of this one. Whatever you do at the end, if you put 1, so this will be 0, plus this will be kept constant, differentiation of this one. So in that one it will be 2 into x minus 1. So first what you will do, I am doing one, I am showing you. First it will be showing this one constant, then differentiation of x plus 1 into x minus 2, plus x plus 1, x minus 2 will be kept constant, then differentiation of x minus 1 whole square, that is 2 into x minus 2. So if you put 1, this is 0, this is 0. So ultimately you will get the answer is 0. So this is 1 minus left hand derivative LHD. Now if you do 1 plus differentiation, same thing will come with a minus sign, but if it is 0, then plus minus doesn't make any sense. So at 1 it will be again differentiable. So obviously you are left with option D. You can check with also at 2 left hand derivative, but because here is only x minus 2, you can see here it is not x minus 2 whole square. If you keep this one constant, differentiation of this one, then you put x minus 2, it is 0. But plus when you do this constant differentiation of this one, x minus 2 will vanish. Next if you differentiate it, it is coming minus this whole square, and here it will be plus. So there will be a difference of plus minus. One will give you 21, one will give you minus 21. So that's why option D is coming. It is not differentiable at 2. Next, if you come to question number 2, f r to r is any function defined. Any function define g r to r by gx is equal to mod of f of x for all function. Then g is 1 1 on 2 or this one. Now you can think of any function. This one I will upload a video on function. I will add a new video on function. You can check how to take mod. Suppose the blue line is this line. Blue line is the original function. Now if you take mod, what happens? The shaded one is the mod. So what happens? The negative portion also become positive, because what is the purpose of mod? If the output is negative, then also it will make it positive. So the shaded portion is the mod, and this one, non-shaded one, the original one, this from here to when it is going like this is your original function. So if you make it this one, so that becomes your mod. Okay, so for drawing I have done. So now for onto. Now what is onto? Onto means if you see R to R, but G output will be always positive. So onto means all its output from here to here, R to R, all its output should be connected, but its output will be connected to R plus only. R minus will never be get connected, because output will never get negative, because the output of range of G is only R positive. It is not, the entire codomain is not equal to range. Here codomain is R, but range is R plus, so that's why it is not onto. So option A is wrong. Now if you come to option B, 1 1, you can see from here it is not 1 1. If you draw a line, it is cutting for the mod function G, it is cutting number of points or more. Okay, so that's why it is not 1 1, obviously, because it will again come back. Mod, it will get reflected from X, it will again come back, so you will obviously get more than one intersection. So obviously mod F, that is G, will never be 1 1, because it is coming reflected from X axis in the positive side, so it will never be 1 1. Next, if you see G is continuous, yes, it is continuous. Because F is continuous, then G will be continuous, because G is nothing, just the reflection of negative portion in X axis, so it will be obviously continuous. Okay, next, the differentiable, if F is no, you can see it is not differentiable, because there is a sharp turn. When it comes here, then it will get reflected like so. This is a sharp turn, so there is a sharp turning is there at this reflection point, so it is not differential, so it is option C. Now question number 3 of similar of these questions we have seen in JEE main, but a little reduced version of this one. Let's see it in detail. And 3, discuss the continuity and differentiability of the function this one. So again, this one you can break it in 1 for x is greater than 0, 1 for x is less than 0, and if you see this one, only this mod, so you can think of you are breaking it at plus 0 minus 0. And if you see this function, it is also defined in two different ways, for greater than 1, less than 1. So the breakpoints are 1 and minus 1, and from mod x, from seeing this mod x, the breakpoint are 0, because above 0 it is 1, below 0 it is 1. So let's check one by one. Let's check at x equal to 1. So these 3 points we will check. So at 1, if you check for continuity and differentiability, if you check left hand limit, so what we will do, 1 minus and 1 plus. So 1 minus will be this one, left hand limit. Okay, if it is less than 1, then x divided by this one. So if you put, I am not using h because it is not required. You just think you are putting a value which is very 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 small, then just smaller than 1, that is very very close to 1, 0.99999 you can think of. So it is only 1, and here you have to check, it is 0.99999 means it will gain output will be 1 only. So it is going undefined if you put it. So obviously it is not differentiable. It is not continuous, that's why it is not differentiable. So 1 is gone. That's why then I will check for minus 1. Okay, now for minus 1, the breakpoints, again I am saying the breakpoint they have given mod x is 1. And what is the meaning of this one? Mod x is less than 1, mod x is greater than 1. Mod x is less than 1 means x is lying between minus 1 to 1. So this is the meaning of mod x is less than 1. It is not simple x less than, that's why minus 1 is also coming. And one is saying mod x is greater than 1. That means another one saying is this and this. This is the meaning of mod x greater than 1. So you can see the breakpoints are 1 and minus 1. Above 1 it is something, below 1 it is something. Above minus 1 it is something, below minus 1 it is something. That's why this minus 1 coming. Now if you see the minus 1, left hand limit, minus 1 minus. So you are coming here. That means minus 1 point something. So that means mod is greater than 1. So that means this function. So if you put it now minus 1 minus, so it is minus 1, and minus 1 minus means minus 1.00001. So if you take mod, it will be 1 only. So 1 plus 1 to minus half. And if you come to RHL, 1 plus means you are going to this side, that is again this one, mod x is greater than 1, that is 1.00, sorry, it is minus 1 plus. So it is minus 1 plus means here you are coming, so that means minus 0.9999, that means you are coming in this function. So that's why this function is used. So if you put minus 1 plus, that means you are putting, what value you are putting? Minus 0.999999, this value. That's what you will think. So minus 0.999, that means it will be 1 only. If you take mod, negative will go. So 1 minus 1, it will be going towards 0 plus. 0 plus means because it is 0.999, 1.999 will give you 0.00001. So it is going, that's why 0 plus. So it is again undefined. Left hand and RHL is not matching, so it is also not continuous differentiable at minus 1. Now think this left is at 0. So at 0, now you think you break this function, because for 0, which function you will take? For 0, you will take only this function. There is no need of considering this function. So this function you can break it in two parts. One for greater than 0, no need of mod. One for less than 0, there is a need of minus. That's why it will be minus plus. Again LHL 0 minus, you will be using this one. Answer is 0. RHL you will be using this one, 0 by 1 minus 0. You can put it 0 plus also, answer will be same 0. And F0 is also 0, because if you put 0, then it is 0 by 1 minus 0. So it is continuous at 0. LHD, so if you do differentiation of this one, U by V format, it is 0 minus, so you will be using this one, 1 minus plus x v square. Then V constant differentiation of U is 1 minus U constant differentiation of V is 1. And at x, if you put finally 0, it will be 1. Similarly for RHD 0 plus, you will be differentiating this one, V square, and this one. Finally if you put 0, it will be same. So obviously it is differentiable at x equal to 0. Now if you come to question number 4a, if function R2R be a function and defined by fx is equal to maximum of these two. What is this function? Maximum, you have to draw then both this function, y equal to x and y equal to x cube. From these two, you have to see at what position which one is maximum, that one will be your graph. So let's draw this one. Y equal to x is a straight line, this is the straight line, and y equal to x cube is always this line. You have to remember this graph. This is y equal to x cube and this is y equal to x, you can see. And it will be below this one. Why? From 0 to 1, because 0 to 1, if you take cube, it will be less than the original number, and y equal to x give you original number. If you x put 0.5, then output is 0.5, but 0.5 whole cube is less than 0.5, so that's why it will go below here also. From 0 to 1, it will be just below this one. Okay, now if you see the maximum, so if I start moving in x direction from here, what is the maximum of these two? Here it is just below, and you have to take the maximum below of y, so the maximum is here. And from these two, which one is maximum? This one. Which one is the upper side? That is the maximum. From these two, which one is maximum? This one. From these two, so the shaded one where I have given this mark, that is your function, the function they have given. Okay, so it is not differentiable. And you can see what are these points where it is problematic. This is minus 1 point, 0 point and 1 point, because at this point the function, there is a sharp turning, because it is changing from one curve to another curve. So there is a sharp turning field is there. So you check at those points. So if you check minus 1, if you do RSD, minus 1 minus, that means LSD. So minus 1 minus means it will come to y equal to x. So if you differentiate it, it is 1. And RSD is minus 1 plus, that means you are going to x cube curve. You can see you are going to x cube curve. So if you do differentiation, it is 3x square. So 3x square, put minus 1, then it is 3. So LSD, RSD is not okay. So obviously it is not differentiable at minus 1. At 0, you check again, LSD, it will be this one, 3x square 0. RSD, it is y equal to x. So if you differentiate, it will be again 1. So it is not again same. Here also, if you differentiate this left hand side, this side will be 1, because it is y equal to x. And right hand side is 3x square. So if you put, it is 3. So again it is not equal. So it obviously they are not differentiable at minus 1, 0, 1, all 3 points. If you like the video, then press the like button and please give your valuable comments in the comment section.